Hello and welcome to another tutorial on SystemVerilog in 5 minutes. Today we'll learn about structure. Structure was not available in Verilog originally. It is introduced in SystemVerilog. It is a concept borrowed from C programming, so you may have studied it before. A structure is basically a variable that wraps around other variables. You can declare a structure variable by using keyword struct. You wrap around the variables you want in the curly braces. In the example here, the structure has a bit, a byte, and an int. In case you're not familiar with the syntax, the first part is the type and the second part is the variable. Now you have two structure variables, s0 and s1. You can access the member of the structure by using dot operator, such as s0.b. Just like other types of variable, you can assign a structure value to another structure variable. Similar to enumeration, because of the wordiness of the structure type, you are recommended to use typedef. The example here shows that the structure is given a shorthand myStruct. myStruct is now a new user-defined type which can be used to create structure variable. Now that we understand the meaning of the syntax, let's take a look at this code to better appreciate its functionality. There are 9 8-bit variables, 3 reds, 3 greens, and 3 blues. Or in another way, there are 3 sets of red, green, blue. From the code, there is really no easy way to tell how the data is represented. In the initial block, the first set of red, green, blue is assigned to some values, and then those values are copied over to the other sets respectively. So at this point, you can pretty much tell that it is 3 sets of red, green, blue, and not 9 individual variables. Those who study image processing will find this very familiar, because red, green, and blue are the basic color description of a pixel. Every color in a pixel is a combination of different shades of red, green, and blue. Imagine that is the case here. You can then use struct to wrap around 3 variables, red, green, and blue. One struct to represent one pixel. And now you can manipulate the variables in a pixel manner. There is no right or wrong with either code, they both work. Accessing variable through struct is more difficult because of the extra dot operator, but creating and assigning struct variables is easier. More importantly though, I believe the design and test intention is better represented with structure. Now let's take a look at the ecosystem around structure. You've already known about dot operator for accessing members of a struct. You can display an individual member value in a conventional manner like this. However, there is a formatter specifically for struct %p. It will print the struct member name and its value, for example, b equals 0 and I equals 0 here. Although I suppose every simulator would have different printing convention. Another aspect of structure variable is that it can be packed by using the keyword packed. In many ways, packed or unpacked structure are similar. The difference between them is that unpacked structure is simply a wrapper. Every of its members is isolated from one another, whereas in a packed structure, its members are concatenated as one big variable, and they collectively forms a larger number. In this case, the unpacked structure has 1 bit and 1 int. The packed structure also has 1 bit and 1 int, but it is also a 33-bit number, combining its members, the bit and the int. Thus, you can access the structure as one numerical variable. The same thing cannot be done on unpacked structure. There are 2 unpacked structure here, S0 and S1, and there are 2 packed structure here, SP0 and SP1. You can assign from one structure variable to another, for example, S0 to S1 and SP0 to SP1. However, you cannot mix and match assign different structure type. For example, SP0 to S1. They are considered as different type of structure. In summary, structure is a type of variable that wraps around other variables. It is generally known as an aggregate type. In the next tutorial, we'll discuss another aggregate type, fixed size array.